And now we are going to talk about fermentation, and sometimes in some dough formulations it could be referred as the floor time. An early stage is 1.5 hours, 1.5 hour time. We have some gas development and heavy dense web structure could be observed, and then tough and rubbery dough we might have. In the mid stage, 3 hour, the mellowing thinner gluten strands start to show. We will have slimy strands and then dense in areas but pools with resistance. And the final stage, 4.5 hour, full development, light tender web structure, thin gluten strands, mellow and soft, and no toughness or resistance is observed. And then if we have excessive fermentation, we will see start to break down. The dough becomes too slack, tearing apart, and then also overgassed. So fermentation, we have physical changes in fermentation. We see increase in dough volume, increase in temperature, even 5 to 6 centigrade, increase in number of yeast cells, and then the dough might become drier. We can have loss of moisture, and then change in consistency. Dough becomes soft, elastic, and it could be even extensible in certain cases. So fermentation, we have chemical changes during fermentation. We have change in the pH. It could drop 5.5 to 4.7. It could be dough becomes slightly acidic after fermentation, and because of production of organic acids and formation of maltase. Maltase is the enzyme that is hydrolyzing maltose into glucose so that yeast can take that glucose and use it during fermentation process. And then we have production of carbon dioxide and alcohol. We know the carbon dioxide in gas form is responsible for the expansion of the dough. And then we have mellowing of the gluten by proteolytic enzyme, because yeast might produce some protease enzymes, and the protease is an enzyme that is decreasing the size of the proteins, so we can actually see some mellowing properties on the gluten because of those protease enzymes produced by yeast, and we might have fermentation loss. Fermentation is the major yeast species we are using in fermentation is Saccharomyces cerevisiae, and yeast is a facultative organism by definition. What that means is it can form the fermentation with presence of oxygen or without presence of oxygen. So yeast is facultative organism, but the bread fermentation, what we consider is an anaerobic fermentation, so without oxygen, because only surface of the dough is exposed to oxygen, and the remaining of the dough there is no interactions with air, so that's an anaerobic fermentation. So in the baking process we have anaerobic fermentation by yeast, and that's why we have carbon dioxide. And here you can see is anaerobic fermentation. We have carbon dioxide and ethanol formation. Then we have expansion of dough, and we observe physical changes in the dough, and we can actually see those rheological changes using some tests, and the spread test is one of them. It measures flow of the flour in the water slurry. So, role of punching during fermentation. As we discussed earlier in the course, we have multiple stages that we actually punch the dough, reshape the dough. Why? Because the role of punching is subdividing the larger gas cells into many more smaller cells, and those create new cells. Mixing of ingredients, bringing yeast cells across more fermentable sugars. If we do not have punching in the process, we can have coarser bread crumb, like larger gas cells. And then also another function of punching is the gluten fibrils. They appear to be more aligned with the punching function. Effect of fermentation on pH, as I mentioned a couple minutes earlier, during fermentation pH drops from 6 to 5, even 4.7 values, because carbon dioxide and water, sugars by bacteria, they are producing organic acids. So yeast is producing carbonic acid, and then naturally found microorganisms. Those are not pathogen, just some natural microorganisms found in the dough, they can produce organic acids. Ingredients such as milk or soy proteins act as buffer and help control the pH. The functions of buffers in biochemistry is to control the pH because they prevent the pH changes. So soy proteins or milk, they are acting as buffer systems in baking formulations to control the pH. So if you look at both mixing and fermentation, the summary of both operations are: mixing is highly hydrated gluten, starch and air bubbles, they are the discontinuous phase, and highly hydrated gluten is the continuous phase. And then we have air incorporated into dough. Yeast cells are fermenting sugars to produce carbon dioxide, and the dough volume and mass is increasing. So this is why we have the leavening of dough system. With the yeast leaven products, dough with characteristic spread. So we have mixed dough, fermented dough, molded dough, and then rested dough. So this is an experimental scheme for determining the spread of wheat flour dough. Dough is mixed, fermented, and molded. Wheat versus the height, we can actually measure the spread ratio. And this is a scanning electron microscopy images of dough after fermentation, and we can actually see nicely organized gluten fibrils, and then we can see round starch granules. Those are embedded into the gluten network. The next stage is during the floor time is the rest time between 0 to 20 minutes following the final mixing that has a positive effect on the dough handling and the product characteristics. At the optimum flour time, the dough will be dry and mellow. It will break clean and sharp with no resistance to pull, and will have a tender web-like structure. The primary objective of yeast fermentation is to leaven the dough as a result of gas production and the retention inside the dough. Yeast fermentation also develops flavor compounds. Those are unique to baked goods, and these are accomplished by biochemical reactions. After saturating the aqueous phase of carbon dioxide leavens the dough, the alcohol dissolves in the aqueous phase and the heat raises the temperature of the dough. And the rate of fermentation is governed by dough acidity. At a lower pH produces more rapid fermentation. Temperature. Approximately 35 centigrade is the optimum for yeast activity, but not necessary for the fermentation. Available food supply. As I mentioned, sugar will be the major source of food for yeast, and then the water content. Drier doughs ferment at a slower rate. And adjustments in fermentation time. The optimum fermentation time represents that point at which the effects of interacting factors, such as character of the flour, yeast level, temperature, formula ingredients, degree of oxidation, all must be in balance. And based on combination of all these effects, the baker can decide on the fermentation time. An impact of fermentation on the final loaf volume is well proven. Here we have 1 hour, 2 hour, 3 hour, 4 and 5 hour fermentation. For this particular flour sample in this experiment, I can say that 2 hour fermentation was optimum, because with 1 hour fermentation, loaf volume was smaller and the crust is darker. Why? Because most of the glucose is not fermented by yeast, and those glucose are contributing the browning reactions. This is why I have darker color, because all these breads are baked at the same time, but we see some differences in the crust color. There are two mechanisms for browning reaction, is caramelization and the Maillard browning. The sugars are part of those, and this is why we have darker color and smaller loaf volume, because not enough fermentation. And if we have 2 hour fermentation, we have nice symmetry and better loaf volume. As we increase the fermentation time, we see decrease in log volume, and we see this bread has very slack, very light color, is because of all the sugars are consumed by yeast, and I believe the dough rheology is changed and there is no sugar left for any color caramelization or the browning reaction. This is why color is paled. So optimum fermentation has significant impact on final bread quality. And these are the internal characteristics. With the 1 hour fermentation, we have smaller loaf volume, very dense crumb. But with 3-4 hour fermentation, we see there are some uneven distribution of gas cells, some holes in the bread. And the 5 hour is very dense, smaller in size. But here I see more evenly distributed and nice crumb structure with 2 hour fermentation. And the flavor substances in bread formed by fermentation, because we know that fermentation is producing unique flavor compounds. Everyone can experience freshly baked bread, that nice smell. So these are the compounds, or what we smell in the freshly baked bread. Because they are very volatile, that's why we can easily smell them. And some of them, they are more volatile than others. So more volatile flavor compounds is some alcohols, pyruvic aldehyde, diacetyl, and isoaldehydes. And then we have also less volatile compounds and even low volatile compounds in combination. That's why we have the unique fermentation flavor in bread formulations. And this is a graph shows that how yeast is changing the rheological properties of dough. And then here the spread ratio is given. The spread ratio is the ratio between the dough height and then the width, and how that's changing during fermentation process. So if we do not have yeast, we see that spread ratio is high. This is only flour and water. As we add yeast, we see that spread ratio is lower because dough is more expanding and becomes more extensible. And this is the example of the longer the fermentation time, there's less resistance to expansion. So this is how fermentation time is impacting the extensibility of the dough and also resistance to expansion. With the 18 hours, we can see that there is almost no peak because of all the protease produced by yeast. They will impact the gluten network. In this example, we can actually see how sugar composition is changing during fermentation process. Because yeast is first going to consume glucose inside the dough. This is the fermentation shown in the x-axis, and then these are the grams of sugar. In this case, we have G is glucose, and then we have maltose and fructose. We can see that with the fermentation, yeast is first spending glucose, like simple sugars, only monosaccharides are consumed first. But then as the fermentation is progressing and the yeast is spending all the simple sugars, then it is producing enzymes to break down disaccharides, like 2-unit sugars. Those will be maltose and sucrose, and their amounts are decreasing later in the fermentation.